Should I start? Okay. Hello everyone. Myself, my name is Jhunjhunwala from IIT Kanpur. So, today I'm going to discuss relations and functions chapter with you. So, basically, firstly, what I will be doing is, firstly, I will be discussing some of the basic things related to relations and functions, and then I will be discussing uh, some past year questions so that you can go through them after the session. So, let's start with the theory part first. One second. So, basically, what a relation is, relation होता क्या है actually में? A relation is an ordered pair which is represented as input slash output, input comma output. So इसका मतलब क्या है? What do we mean here is like you can say that, let's say there is some function, and the function, for a function, x is our domain and y is our range. Basically, what is domain, what is range? If you don't know, it will come ahead. So basically, input represents x and output represents y here. So what you are gonna do is you are just making a relation, and relation is something which is defining one set to other set. Matlab, you can say that defining a relation from real number to real number, or you can say that defining a relation from real number to natural number. So basically, this is the, let's say you are defining a relation from A to B. So input is the element of A and output is the element of B. Okay. So the relation shows the relationship between input and output, whereas a function is a relation which derives one output for each given input. Now, what is the basic difference between relation and function? Firstly, first thing first, remember it for your lifetime that every relation is matlab, you can say that every function is a relation, but every relation is not a function. Means function is a sub part of relation. It is not necessary for a function. It is not necessary for a relation to be a function, but it is necessary for a function to be a relation. So basically, what a function is something like. Let me draw it. See, one second. What a function is? A function is a relation which describes that there should be only one output for each input. Matlab, you can say that, let's say, one output for each input means if you are, let's say, consider y equal to x square graph. So what is there in y equal to x square graph? For x equal to plus 2, your answer is 4, and for x equal to minus 2, your answer is again 4. So basically what I'm saying is, for two values of x, matlab, for two values of domain, you can get one value of y. See, in y equal to x square function, you can see that for x equal to plus 2 and for x equal to minus 2, for both the function, for both the numbers, you are getting y equal to x square equal to 4. So basically, what a function is, you can have two x values and that will go to one y value, but you can't have two y values for one x. Like you can't have a function in which you put x in your domain and you get two different range. Like you get two different y's. Like, let's say if you are defining some function, basically it's not a function, but I'm just saying if you're defining something in which your, let's say, x equal to minus 2 goes to y equal to plus 2 also and y equal to minus 3 also, means what I'm basically saying is, for one value of x you can't imagine two values of y. If it is so, then it is only a relation and not a function. So I think you got the point between difference between function and relation is, basically, there should be only one output for each input. For each value of x, there should be only one value of y. Or we can say that a special kind of relation, a set of ordered pairs which follows a rule that is every x value should be associated with only one y value. Got it? So this is the main thing behind the logic of functions. So I hope you got it. So let me move ahead. So now what is domain and range? Domain basically is, you can say that domain is something what we're talking about till now. Let's say y equal to x square. Again, take the same example, y equal to x square. So the values of x which you will put in y equal to x square, like let's say what I told you just now is +2 and -2. So those +2 and -2 values which you are putting inside a function y equal to x square, you can say that those values come inside the range, come inside domain. So what is basically domain? Domain is basically collection of first value in the ordered pair. Matlab, you can say that you have defined the ordered pair in which first was input and second was output. So collection of all those inputs is nothing but domain. The x values for which your function is defined is known as domain. But you can't take something in your x value which will make your function go to infinity or something like that. Then that x will not be in your domain. So domain is basically that part of a function for which you get some value of y. So if a function is clearly defined for some value of x, then you can say that that value of x is said to be domain of our function. And talking about range, what is basically range? Range is the image of x, means y. Let's say your function is y equal to x square. So all the plausible values of y belong to range of a function basically. So let's say again y equal to x square. So for y equal to x square, you put x value plus 2, x value minus 2. For both, you are getting 4. So 4 is in the range of y equal to x square. You put any value of x, and whatever values of y you are getting, all those values of y constitute your range. So basically, all the images of domain, all the images of your x basically form the collection set of your range. So it is a collection of second pair and the ordered pair. Or you can even say it in the ordered pair terms. In ordered pair, firstly we will be having input and then we will be having output. So collection of all those output values is nothing but range of a function. Okay, so all plausible values of y constitute your range, and all plausible values of x constitute your domain. So this is the main crux of the chapter about what the function basically is. Your function starts from here only. So now let's define an example. In a relation -2, 3, 4, 5, 6, -7, and -2, 3. Let's say this is a relation. I'm defining it from -2, I'm going to 3. I'm defining some set from A to B in which -2, 4, 6, and -2 are my elements of A, and 3, 5, -5, and 3 are elements of B set. So basically what I'm saying here is I'm defining a relation from A to B such that -2 is going to 3, 4 is going to 5, 6 is going to -5, and -2 is going to 3. Let me draw it if I can. Okay, so let's see. Let's say this is my one block and this is my second block. Okay, so this block will contain all the values of x and this block will contain all the values of y. Okay, so basically what is x? X is all those values which will come inside the domain of a function. And what is y? Y will constitute all those values which will come inside the range of a function basically. So basically what is x here? Here x is -2. Here x is -2, 4. Sorry. -2, 4. Then you have 6. And then you have -2 again. So since we have written -2, we don't have to write it again and again. So basically what you're doing is you're defining a function from this set of values, let's say A, to another set of values, let's say B. And B will constitute all the values of Y, means the range of your function. The image of these domains. So here it will be 3, then it will be 5. You can write it in any order, it doesn't matter at all. 3, 5, -5, and then 3. Again, okay, 3 we have already written basically. So -2 is going to 3, then 4 is going to 5, and 6 is going to -5. Okay, so basically this is the way you define a function. You define a relation basically, and basically function is a part of relation only. That's why I'm saying. So this is the set of your domains, and this is the set of your range. So basically you are going from values of x to values of y via a relation defined on these two sets. Let's say this set is A and this set is B. Cool. So basically, minus 2, 4, 6 is the domain, and 3, 5, minus 5, the second part of the relation, which is output, is what we call as range. So I hope you have understood it from this example. So moving ahead. Now coming on to types of functions. So how many types of functions are there? There are basically types functions. Types are many, but